Hi, welcome to test taking advice for the New York State Chemistry Regents Exam. My name is Dr. English and, I'm going to give you a little bit of advice today. Just so you know, all questions referenced in this particular tutorial are coming for the most part from the January 2017 exam. And if you want to look at that exam in more detail along with the answer key, please see the website given at the bottom of the screen. What you should consider prior to taking this exam. What should you do the night before the exam? Moments before the exam? When you first start the exam? How to use your reference tables? Multiple choice questions 1 through 50, also known as A and B1. Looking at the free response questions 51 through 85. And then some final thoughts. The night before the exam. What you should do. Do something that's going to keep you focused and calm. Maybe take a walk. If you need to study some more, that's fine, but just keep it focused and don't overwhelm yourself. And then finally, go to bed at a reasonable hour. What you should not do. Do not try to stay up and learn everything the night before the exam. Trust me, it's not going to work. And do not stay up all night studying. That too is not going to work. Moments before the exam. What you should do. Eat breakfast. A healthy breakfast is preferred. Make sure you have everything that you need for the exam. This includes pens, pencils, and a scientific calculator if your school is not providing you one. Stay focused and confident. A positive attitude will go a long way. What you should not do. Skip breakfast. That's known as a bad thing. Bring electronics into the classroom. You're going to have to give them up anyways, and if you do bring your cell phone, make sure you turn it off and give it to your proctor. Freak out people around you by talking about what you studied, what you didn't study, asking if they studied it. Trust me, no one wants to hear you talk about this. Don't freak out people around you. When you first start the exam, take a deep breath and center yourself. You can do this. Consider a brain dump. Writing down any information that you are afraid you are going to forget and want to make sure that you remember. And I'll talk about this more in a second. Approach taking the test in a manner that is most comfortable for you. If you want to start with the open-ended, start with the open-ended. If you want to start with the multiple choice, start there. There is no specific way of how you have to take this exam. Now let's talk about the concept of a brain dump and what do we mean by that? Look at the question below. What is the number of electrons in a completely filled second shell of an atom? What formula would you use for this? A formula that is not on your reference table but you need to know is the 2n squared formula. So if we take the number 2, because they're talking about the second shell here, and we substitute the 2 in right here, 2 squared is 4 times 2 is 8. So the maximum number of electrons in the second shell is 8 electrons, which is the correct answer for this question. Let's look at another common question where you need to know a formula that's not listed in your reference tables. The table below shows the atomic mass and the natural abundance of 2 naturally occurring isotopes of lithium. Which numerical setup can be used to determine the atomic mass of naturally occurring lithium? So the formula that you want to use here is natural abundance times atomic mass plus natural abundance times atomic mass. And I'm only saying that twice because I'm only given 2 different isotopes. So what I want to do is take that natural abundance, multiply it by the atomic mass, add it to the next isotope, its natural abundance, turning it into a decimal, times its atomic mass. This is the correct setup for this particular problem, which of course is answer number 2. Notice again here they're asking for a numerical setup, so they're not expecting you to calculate an answer. But this formula right here, natural abundance times atomic mass, is not in your reference table, and that is something that you need to know. That's why we say doing a brain dump ahead of time to make sure that you remember this particular formula might be a good idea. Using your reference tables. Many of the questions on the exam are linked to the reference tables. Never guess when you have access to all those reference tables. It is worth taking a moment to check yourself with a reference table to help you answer a question. So you might need to know the specific heat capacity of water. That's found on table B. Or maybe you need to tell the difference between sulfate and sulfite. That's on table E. Maybe you need to figure out whether a redox reaction is spontaneous or not, or predict the products of a single replacement reaction. That's on Table J. How about knowing some names of common acids? That's on Table K. Or Table L, which will give you the common bases. Maybe you need to figure out how to name an organic compound. Make sure you go to Table P. Or differentiating between an alkene, alkane, or alkyne. That's totally Table Q. Or figuring out the percent composition of an element. You're going to go to Table T, and that will give you percent composition by mass, the formula for that. And finally, maybe you need the combined gas law, and you need to differentiate between pressure, volume, and temperature, knowing that temperature is always going to be given in Kelvin. All of these and more are listed in your reference tables. Use them. Multiple choice questions 1 through 50, also known as Part A and B1. You want to read the questions slowly, underline key words, reread the questions again, read all the answers before making a choice. When in doubt, scan your reference tables for a hint. If you're unsure of an answer, use the process of elimination. If a question directs you to use a reference table, do it, and make sure the units in the question are consistent. For example, let's look at the question at the top. Which temperature represents the highest average kinetic energy of the particles in a sample of matter? Highest average kinetic energy basically means highest temperature. So it's very easy to look at all these and be like, oh, the answer is definitely number 1 because that's the largest number. What we need to do here, though, is make sure that all of these are in the same unit. So if 1 and 2 are in Kelvin, we need to make sure that 3 and 4 are also in Kelvin. So what we're going to do here is add 273 to both of these, and when we do that, we find that 273 plus 27 is going to give us 300 K, and 273 plus 12 is going to give us 285 Kelvin, and that means this final answer is actually going to be 3 instead of 1. So be careful of that. Free response questions 51 through 85, also known as B2 and C. When you respond to these types of questions, we need you to write clearly. Make sure your answer is large enough to read. This can be a problem, believe it or not. If we can't read it or understand it, we cannot grade it. In your head, read your answer to yourself. Does it make sense? If it doesn't make sense to you, it's not going to make sense to us. In these types of questions, they're going to assess you both on content and skill. You can expect to see the following types of questions: interpreting a graph or chart, writing a numerical setup, writing your response in terms of a specific focus, comparing given content items, and the term determine commonly indicates the use of a calculation. Writing a numerical setup. The first thing that you want to do is read the question slowly. Then, absolutely, you should write out the formula from Table T if applicable. Take your time when substituting values into a formula. Make sure you put the right information in the right spot. So let's look at an example. The densities of 2 forms of carbon at room temperature are listed in the table below. So we have densities of graphite and diamond. A student calculated the density of a sample of graphite to be 2.3 grams per centimeter cubed. Show a numerical setup for calculating the student's percent error for the density of graphite. So the first thing that you should do is to go to your reference table and write out the formula for percent error. There it is, right there. Percent error is equal to the measured value minus the accepted value divided by the accepted value times 100. So we're going to write that out first. Now the measured value is the 2.3 grams per centimeter cubed. The accepted value for graphite is right here, what is listed in the table. So when you write this out, you should see something like this. The measured value by the student minus the accepted value divided by the accepted value times 100. And that's it. You do not need to write an answer if you don't want to. What we're testing here is the numerical setup. Questions involving calculations. These questions typically start with the word determine. So again, you're going to read the question slowly, write out the formula from Table T if applicable, take your time when substituting values into a formula, label, label, label. Labeling will help guide your answer, show using the correct math, check yourself, and make sure that it makes sense. So let's look at this example. Determine the percent composition by mass of oxygen in CaCO3. Now, in the question already, they gave us the gram formula mass of CaCO3 to be 100 grams per mole. So the first thing we're going to do is write out our formula for percent composition. So that is percent by mass is equal to part over the whole times 100. Then what we're going to do is we're going to substitute in our values. So the part here is the oxygen. Oxygen right here, and there's 3 of them. The atomic mass of oxygen is 16 times 3 divided by 100 times 100, and you should get 48%. Now again, you don't have to show your setup. Definitely worthwhile in my world to actually write out the setup, make sure that you have everything set up correctly, and then do your calculation at the end. Writing your response in terms of. In terms of answers are really, really important to understand how to approach. An ideal answer will be written with reference to the content specified in the stimulus. Let's look at an example. Carbon monoxide is a toxic gas found in automobile exhaust. The concentration of CO can be decreased by using a catalyst in the reaction between carbon monoxide and oxygen. This reaction is represented by the balanced equation below. Explain, in terms of collision theory, why an increase in temperature increases the rate of the reaction. Let's look at the responses that were accepted. The rate of a chemical reaction increases because the reactant molecules move faster and collide with more kinetic energy. Increasing the temperature causes more frequent collisions. As molecules acquire more kinetic energy, the probability of effective collisions increases, and more reactant molecules collide with sufficient energy. The key thing that I'm trying to point out is that it needs to be in terms of collisions. Every single one of these responses involves either the word collisions or collides. So make sure that you stay focused on that when you're writing your answers. Compare question. An ideal answer for a compare question will contain both items being compared. Let's look at an example. Compare the energy of an electron in the first shell of a cadmium atom to the energy of an electron in the third shell of the same atom. Here's the accepted responses, but are not limited to, but there could be other answers accepted by the people grading your test. So an electron in the first shell has less energy than an electron in the third shell. So you'll notice in this answer, they're mentioning both the electrons in the first shell and the third shell. The second answer states the third shell electron has higher energy. Now, personally, I'd rather see that say the third shell electron has higher energy than the electron in the first shell, but you know what? That's okay. Like I said, this is an ideal situation. And finally, electrons in the third shell will have greater energy than electrons in the first shell. So again, like I stated before, an ideal answer will contain both items being compared. Final thoughts. Go to bed at a reasonable time and make sure you eat breakfast. Stay calm before the exam. Take a deep breath and believe in yourself. Slowly read and then reread the question. Use your reference tables when appropriate. Write out the formula and check your calculations. Your answers should be in context with the question. And finally, avoid using the word it. So do your best on the Chemistry Regents exam. Have a great day.